Hi, everyone. Thank you for standing by. As a reminder, this event is being recorded and will be archived on pumpsandsystems.com. I'm Amy Hyde, Editor-in-Chief of Pumps and Systems Media. Welcome to How to Optimize Process Visibility in Harsh Environments, Solving Safety, Corrosion, and Pressure Challenges, sponsored by LJ Star Incorporated. Our presenter today is Scott Klutzer. Scott is the Director of Business Development at LJ Star Inc. He has more than 20 years of experience providing innovative process observation solutions for the pharmaceutical, chemical processing, and oil industries. Scott is a graduate of the University of Akron with a degree in sales and marketing. At this time, it is our pleasure to begin the webinar. Stay tuned after the presentation for the Q&A session, and please send your questions through the Ask Question box, and we'll get to as many of them as possible. Now I'll turn it over to Scott to begin the presentation.
Good afternoon, everyone, and thank you for joining me. My name is Scott Klutzer, and I'm the Director of Business Development at LJ Star Incorporated. Today we're going to talk a little bit about how to optimize process visibility in harsh environments with a focus on solving safety, corrosion, and pressure challenges. This is a topic that is often underestimated. Process visibility equipment tends to be treated like basic accessories, but in reality it plays a direct role in operator safety, process control, maintenance planning, and product quality. If operators can't clearly see what's happening inside a vessel or a process line, they're forced to make decisions with incomplete information, and that can definitely lead to serious consequences. So what I'd like to do today is shift the conversation from thinking about sight glasses as just a standalone part to thinking about visibility as a complete system. A few quick housekeeping notes before we begin. The slides and recording will be available afterwards, so there's no need to feel like you have to capture every detail in real time. So please feel free to ask questions in the chat as we go. We'll have a way to collect those and answer them at the end of the presentation. And as is standard for most of these webinars, attendees are going to be on mute. But my goal today is to give you practical guidance on what you can take back into your specifications, your operations, maintenance, and your troubleshooting discussions at your facility. To frame the discussion today, process visibility equipment is often treated as forgotten hardware. It's easy to think of it as just a window into the process, but poor visibility can contribute to a wide range of operational issues at the facility. Some of the things that you can see would be safety incidents because you could have pressure buildup, leaks, or abnormal process behavior, and that may not be recognized early enough without any type of visual inspection. It can also lead to lost batches and wasted product when you have foaming, contamination, or phase changes that may be missed in a process. It can also reduce process control because operators are reacting based on assumptions rather than what they can actually see during the process. In many facilities, it even affects inspection tasks such as verifying vessel conditions after cleaning or checking for damage and residue before a new batch begins. And this could be something as simple as verifying that a spray ball was functioning properly to make sure that the tank is being cleaned out entirely. So what this webinar is going to focus on is a more effective system-level approach to process visibility. That means not looking at just the glass or just the light or the camera independently. Instead, we're going to talk about how all those elements can work together as a package. We'll cover glass type specification, lighting considerations, and remote monitoring with cameras, and the importance of supporting hardware like clamps, gaskets, accessories, and bolting. The main idea is pretty simple. Even if one component is of high quality, the overall visibility result can still be poor if the system isn't designed as a complete unit. A great sight glass with a bad light can still give poor view to the operator. A camera mounted to a bad viewing angle or a bad sight glass can give you a poor image remotely, so the system has to be coordinated from the start as a complete kit. LJ Star brings years of application experience across a wide range of industries, including pharmaceutical, chemical, refining, biogas, food and beverage, and other industrial markets. That range matters because visibility challenges are not a one-size-fits-all, as we'll talk about as we go through these slides. The demands of sanitary pharmaceutical processes are very different from those of a corrosive chemical reactor or a high-pressure refining application. The products may look similar from a distance, but the material selection, safety considerations, compliance requirements, and maintenance expectations can be very different in all those different markets. That's why application knowledge is so important in getting the specifications right at the start. So here's a look at where we're heading today. We'll begin by talking about why poor visibility compromises process control and safety. Then we'll move into how sight glasses, lighting, and cameras should be integrated correctly. We'll discuss how to specify process lighting, when cameras make sense, and what to consider when adding them. From there, we'll address material selection for extreme temperatures and aggressive chemicals, how to avoid blind spots and false readings, and how better planning can improve maintenance access and reduce downtime. Finally, we'll talk about the balance between image quality, durability, and life cycle cost, because the cheapest upfront option is often the most expensive over time. When operators can't clearly see what's happening inside a vessel or a pipeline, they're essentially being asked to manage the process with incomplete information or essentially blindly. That affects decision-making in real time. Are we seeing what's happening inside the tank? Is it foaming? Is the vessel truly clean after washdown? Is there separation occurring as expected? Is there residue on the wall, or is that just distortion or glare of the tank? Those aren't small questions. They directly affect product quality, operator response, and process efficiency. I always like to emphasize that process visibility is not a secondary concern. It supports safe operations, efficient troubleshooting, and consistent product quality, as well as reliable process control. In many cases, it also supports vessel inspection after cleaning. If you can't confirm cleanliness or condition visually, you increase the risk of product contamination or rework inside your tank. At the end of the day, a ruined batch or a wasted process costs both money and time. An optimized system helps reduce both of those issues. So there are four major consequences of inadequate visibility that we see repeatedly at LJ Star. First is safety incidents. If there's a pressure buildup, if the sight glass leaks, or if equipment stress goes undetected, workers can be exposed to unnecessary risks. In harsh services, the stakes are even higher because the process conditions themselves may already be hazardous and may definitely cause harm to the operators. Second is lost batches and product waste. If operators miss foaming, contamination, incorrect fill levels, or phase separation, the issues may not be discovered until the batch is compromised. By that point, the cost has already been incurred. Third is misdiagnosis and false readings. This one is especially important. Etched glass, fogging, poor lighting, or glare can make a vessel appear dirty, scratched, or contaminated when it really isn't. It also makes it difficult to see when it really is. That can trigger unnecessary cleaning, incorrect process adjustments, or the wrong maintenance response based on what you think you're seeing but don't have an accurate picture of. And fourth is unplanned downtime. When components are incorrectly specified or maintained reactively instead of proactively, emergency repairs and shutdowns become much more likely. All four of these problems are considered to be expensive, and more importantly, they are often preventable. This slide is going to get to the core concept of the presentation. A coordinated system of sight glass, lighting, and camera provide the full visibility into the process. A single component on its own cannot deliver reliable visibility. A camera without the correct placement may miss the exact area where product behavior matters most. Lighting without the right sight glass can create glare, distortion, or misleading reflections, and a sight glass without proper lighting may technically provide access to the vessel, but not a useful view for the user. So when we talk about process visibility, we need to think beyond individual components. We need to ask whether the total viewing system is engineered for the application. Is the viewing zone correct? Is the material right for the chemistry and the pressure? Is the lighting positioned to illuminate rather than obscure? If remote monitoring is needed, is the camera actually seeing what the operator needs to see and not just viewing into a tank? That systems mindset is what separates basic hardware from an effective process visibility solution as a complete package. So the three pillars of process visibility are straightforward: the sight glass, the lighting, and the camera. The sight glass provides the physical window into the process, what the operator is going to be looking through. We need to make sure that it's safe, that it's durable and appropriate for the conditions, because you're putting a person or an operator right in front of the equipment, usually under some sort of pressure. The lighting makes the process visible in practical terms. Without proper illumination, even the best sight glass can provide poor visual information. The camera extends the visibility beyond the vessel itself, allowing remote observation, documentation, and multi-user access. This definitely comes in handy when you have operators that may have multiple facilities and need to be able to view each of the facilities from one location. The important point here is that each pillar solves a different problem. None of them fully replaces the others. When properly combined, they create a complete visibility system. Poor visibility is not always caused by the sight glass itself. In many cases, the real problem is inadequate or poorly positioned lighting. If the lighting is wrong, operators may miss what they're looking for inside the tank, such as foaming, fill levels, separation, or other important process conditions. Bad lighting can also create the false appearance of scratches, residue, or contamination within the tank. In stainless steel vessels especially, reflections and glare can distort what the operator thinks they're seeing, especially after a cleaning process. When visibility is unclear, operators compensate by guessing more, checking manually more often, or spending more time troubleshooting the process. That slows response time and reduces confidence in the process decisions. So the bottom line is this: if the operators can't see clearly, they can't respond confidently. Lighting is not an accessory to add later. It's a critical part of the design and makes sure that the operator can see inside that dark tank. So effective process lighting should be selected as part of the visibility system from the beginning, and certainly not added later as an afterthought. We get a lot of applications where customers say they'll add the sight glass and then just use a flashlight to see inside the tank, but the flashlight's not sized properly and it doesn't allow them to see everything that they want to see inside that tank. Several factors are going to matter. Vessel size and viewing depth are two of the main ones that we'll try and find out. A small vessel and a large tank have very different lighting needs. Mounting position and viewing angle also matter, because the wrong angle can create reflections off the glass rather than useful illumination, and that will cause the operator to not be able to see inside the tank. Reflective interiors, especially stainless steel, make glare control important. Hazardous location requirements must be considered in classified areas. Things that we look for are temperature, washdown, what type of outdoor protection the light has can affect the durability of the equipment. And maintenance accessibility matters too, because even the right light becomes a problem if it's difficult to service or to clean. So lighting specification is really about matching illumination performance to the actual application environment. So there are several common lighting mistakes that we see in the field. One is assuming any bright light will work. As I mentioned before, lots of our customers will try and use flashlights. They say they think they're bright enough, but brightness alone isn't necessarily the goal. The question is whether the light creates a clear, usable image for the operator to see inside the tank or the pipeline. Another common mistake is placing the light where it creates glare rather than visibility. That often happens when lighting is added without considering how the operator or the camera will view the process. We also see systems with insufficient lumens for larger vessels, which leaves important areas underlit. Other issues include ignoring condensation or product buildup on the sight glass and forgetting hazardous area requirements, as well as treating lighting separately from the glass and camera. A system can be bright and still produce poor visual data if it hasn't been engineered correctly. So the real goal is clarity, not just illumination. So a camera is often the right choice when direct observation is unsafe, inefficient, or inconsistent. So for example, elevated or hard to access vessels may make regular manual viewing impractical. Up here in the Northeast, we get a lot of snow and ice due to the cold temperatures, so sending someone up on an elevated platform to look inside when it's iced over isn't always the best approach, whereas you could just visually observe remotely what's happening in that tank and not have to send operators out. Hazardous or explosion-rated areas may limit how often personnel should approach or go into the rooms that the equipment is in. And then high pressure and high temperature operations may make remote observation the safer option because you don't have to worry about a piece of equipment blowing out on a person or them burning themselves in a high temperature application. Cameras are also useful when a process requires documentation or review, or when multiple stakeholders need access to the same live view. So with regards to documentation or review, it could be in the food and beverage markets where there's a batch recall and they want to go back and view the process to make sure that nothing had actually occurred causing an issue with that batch. It might also include having remote operators or supervisors, quality teams, or engineering personnel that need to get involved. The key is that a camera adds value when it improves access to process information without increasing risk or inefficiency, but it only works well when the rest of the visibility system is already sound. So adding a camera successfully means designing around the operating environment, not simply attaching a camera and hoping for the best. The first consideration is hazardous location ratings if the environment requires it. Mounting flexibility at the site port is another important factor because the camera must actually capture the correct process zone or area of the tank that you want to see. Image quality in low light conditions matters, especially if visibility is already limited. Connectivity to the control room or network may also be important depending on how the live feed will be used. So maintenance and cleaning access should be considered so the camera doesn't create service complications. And of course, long-term durability and total cost of ownership matter just as much as initial image quality. Most importantly, a camera doesn't solve a bad view. If the sight glass is etched, the lighting is poor, or the placement is wrong, the camera simply gives you a remote version of the same bad view. So all that must be taken into account to make sure that you have a good, complete system. This slide essentially summarizes the idea of a complete process visibility system. So you've got the cameras, the lighting, and the sight glass, which each solve a different part of the challenge. The sight glass gives you a safe and durable window into the process, normally separating you from pressure, temperature, whatever might be the issue to where you can't open that system up. The lighting provides a clear and accurate view inside that vessel, allowing you to see in a dark environment. And the camera enables remote access, monitoring, and documentation, covering all the issues that we talked about before, where if there's a batch recall, if there's a cleaning issue, whatever it might be, the camera will allow us to monitor and document those processes. When they are integrated properly, the result is better worker safety, better process control, faster troubleshooting, and improved maintenance planning and strong documentation and traceability, which is a massive plus for the facility. That's really the outcome we're aiming for. We're not just trying to install hardware, we're trying to help operators and engineers make better decisions with clearer information. Now, once we move into harsh environments, material selection becomes critical with regards to these products. Temperature, pressure, and chemical exposure each place their own demands on the system, which is why when you come to us for a quote or questions, we're going to want to know temperature, pressure. We're going to want to know these key items immediately because that's going to help dictate how we design a system. So one of the most common and costly mistakes in process visibility is specifying the wrong glass type. A glass that performs well in a mild application may degrade very quickly in acidic environments, caustic service, or high pressure conditions, thermal cycling, or abrasive media. In many applications, we're told that when you're talking about a mild application, if the temperature is around ambient, that chemical works fine. But when those temperatures significantly increase, that same chemical is no longer what we would consider mild. It would become a very acidic environment. So we need to take those things into account. When that happens, the visibility degrades on the glass, the maintenance increases, and the failure risk can rise because you're etching the glass. So the decision is not just about whether the glass works on day one, it's about how it performs over time under real service conditions. This is where application-specific specifications become essential when we're working with you. Specifying the right material from the start and building inspection into the maintenance plan is what's important. Different glass materials have different strengths and weaknesses, as you can see from the list that we have on this slide. Some handle thermal stress better, some offer stronger resistance to certain chemicals, and then on the other side, some may be more vulnerable to etching or mechanical damage depending on the application. The key point for the end user is not necessarily to memorize every single glass type, but to understand that glass selection must be based on real operating conditions, not just pressure class or dimensional fit. It's important to try to figure out what your application looks like and understand that that application can change. So it's important that you constantly monitor the sight glasses that are installed and make sure that the glass is working in that application. I've seen applications where one plant is supposedly running the same as another plant, but one sight glass is more etched than the other. And after talking to them, it's because they did make minor changes in the process, even though they were separate plants running supposedly the same process, but the temperatures were different in each facility, which allowed more etching to occur to the glass because of those increased temperatures. So it's important to make sure that not only do you choose the right material, but that you also continue monitoring that material through these processes. Now, the glass is only one part of the system, as we've talked about. The housing and gasket materials also have to match the process. So, for example, 316 stainless steel is often standard for many sanitary and pharmaceutical applications, while duplex stainless, such as in Metaglass, offers a stronger corrosion resistance in more demanding environments, such as oil and gas applications. Gasket chemistry has to match the process media as well, because even if the metal and glass are correct, an incompatible gasket can still lead to failure or leakage of the sight glass. In corrosive applications, shields such as mica, FEP, or KELF can help extend service life, and in hazardous areas, lights, cameras, and fittings all need properly rated housings. So again, this is a system discussion. If one material in the stack-up is mismatched, the whole assembly becomes vulnerable to attack. So poor visual data usually has specific causes, and many of them are preventable. Wrong glass types can lead to gradual etching and opacity. Inadequate lighting can hide fill level, foaming, or separation. And poor sight glass placement may miss the most important zone inside the vessel for what the operator was looking for. Fogging and condensation can obscure the view. Product buildup can block the glass surface, and the wrong illumination angle can create glare for the operator, especially in reflective stainless steel vessels. So what's important here is that not every visibility problem is a hardware failure. Sometimes the hardware is intact, but the system still produces misleading information because of placement, lighting, or application mismatch. So it's extremely important that in the beginning design stages, we determine what is important to the facility and the operator, and what are they looking for in each of the individual processes. So when there's a visibility complaint, it's important to diagnose the full viewing system rather than assuming the glass itself is the only issue. Now, this normally occurs after a system has been installed and the operator determines that something is not correct. So we've got to look at the entire system as a whole to determine what's wrong. On this particular slide, we outline several practical ways LJ Star addresses some of these issues. For applications that demand strong resistance to etching and mechanical stress, we specify Metaglass fused sight glasses that can be a strong solution. Lighting should be sized to the vessel in the application, which is where LumiGlass LED process lighting comes in. Beyond the hardware itself, proactive cleaning and inspection protocols are essential, so placement analysis helps ensure critical process zones are visible. And where condensation or buildup is expected, wiper and sprayer assemblies can help maintain a clear line of sight. The main takeaway is that solving visibility problems usually requires both the right equipment and the right maintenance strategy. Unplanned downtime from process visibility equipment failures is largely preventable. The key is correct initial specification, as we've talked about so far, regular inspection, which is extremely important just to make sure that the equipment is still functioning properly as designed, and planned maintenance and treating sight glasses, lights, and cameras as critical assets rather than minor accessories. When those components are treated as low priority items, they're often only addressed after failure, and that tends to mean emergency labor, rushed replacement, and production disruptions. Now, this comes up a lot for us because we are constantly having to do rush 24-hour turnarounds on sight glasses because they have allowed the unit to fail in some way. A better approach is to build visibility into the equipment as far as broader reliability and asset management strategy, and that helps shift the facility from reactive maintenance and planned maintenance. So it's much better if you're constantly checking the equipment over and making plans in the future, knowing that the product or the sight glass needs to be replaced in the future, and having orders or replacements set to go. And that way you're not waiting until you have a complete failure, at which point you've got to shut your system down, wait for the equipment to come in, and then get it installed immediately at a significantly higher cost. When evaluating process visibility equipment, there are several performance specifications that should always be reviewed. These include pressure and temperature ratings, chemical compatibility, impact and mechanical strength, optical clarity over time, hazardous area requirements, and serviceability. Depending on the application, documentation and compliance standards may also be critical in these applications. What matters is not just whether a component can be installed, but whether it can perform reliably over its expected life under real-world conditions. Strong specification discipline up front reduces troubleshooting later. This is one of the most important habits to develop. Always connect the specification sheet back to the actual process environment so that we can make sure that the product that we are recommending or that you're requesting meets all the proper requirements. So here are a few maintenance best practices that can make a significant difference. The key is to inspect regularly for etching and clouding, as well as pitting. You want to track tag numbers. It's always recommended that you tag the individual units that are in the field so that you can go back and know which ones you're talking about. You want to look at material specifications, and you want to you want an inspection history of the unit so you know exactly what is installed and how it is performed over time. Because again, we don't always know what that process is going to be like, so you kind of want to put that first one in service and then determine what that life is. We constantly get questions about life expectancy, which is something that we can't answer because every application is quite a bit different. Also, you want to verify gasket compatibility anytime the process chemistry changes, because even a small change in media can affect seal performance, and seals are extremely important when it comes to our sight glasses. Protective guards should be used at all times where applicable. Findings should be documented with photos and inspection logs, and manufacturer torque specifications should be followed during installation, because improper bolting can create stress and shorten service life. Most companies that you're buying this equipment from should be able to supply you with a proper installation manual that you should follow when you install these units. These practices are pretty simple, but they're highly effective in reducing unexpected failures of the sight glasses. So this is also where procurement and engineering priorities often have to align. Selecting process visibility equipment based only on purchase price is not the way to go. The true cost includes replacement frequency, downtime risk, labor, process loss, safety exposure, and compliance issues, but normally many of those aren't taken into account because purchasing is looking for as much in cost savings as possible, but they're not taking into account the overall life of the product cost. So a low-cost component may appear to save money up front to the purchasing person, but if it clouds, etches, fails prematurely, or requires frequent service on the service side from maintenance, it then becomes much more expensive over time because you've got the maintenance time, you've got the materials, the cost to replace, So the conversations should be not limited to initial price. It should focus on the life cycle value, the reliability, and the consequences of failure. And purchasing should really take maintenance's point of view into what they believe is a superior product, because the last thing maintenance wants to do is constantly be maintaining these products and replacing them regularly if they're not designed properly, or if they were purchased because they were the least expensive but they last the least amount of time. So these all need to be taken into account. So this slide is going to highlight the hidden costs of the low cost or cheap approach to purchasing equipment. For example, frequent replacement cycles quickly erase any upfront savings. Etching and haze can create unplanned shutdowns because visibility becomes unreliable. And in worst case scenarios, a catastrophic gas failure creates risk for personnel and equipment. And that's the last thing you want, because with a sight glass, normally the operator is standing inches away from the glass looking through some sort of a pressurized tank. So the last thing you want is a catastrophic failure where the glass blows out on an operator. Emergency repairs often come with expedited shipping, which we run into often. That would include overtime labor to install and pressure on the maintenance teams to get the equipment installed quickly. So in many cases, we may be delivering something on a weekend, or we're pulling personnel off and charging extremely high expedite costs that are associated with getting that product to our end users as quickly as possible. So there's a lot of additional cost associated with emergency repairs. There's also compliance risk if installed equipment doesn't meet the required standards or documentation expectations, which you normally see with low-cost sight glasses where they don't supply the required documentation. So while low purchase price may look attractive on paper, especially to purchasing, it often just shifts the cost and risk into operations and maintenance, where the impact is much greater. By contrast, the right spec and the right product creates long-term return. Longer service life reduces total cost of ownership. Proactive inspection aligns replacement with planned shutdowns instead of emergency outages. And Metaglass fused design helps reduce the risk of sudden catastrophic rupture. So using a safety sight glass, for example, instead of a standard sight glass, definitely reduces the chances of having any type of a catastrophic rupture. Planned maintenance reduces emergency callouts and documentation such as DIN 7079, 80, USP Type 1, ATEX, CRN, supports compliance and audit readiness for the facilities. So the key question is not what is the cheapest sight glass. The better question is, what is the cost of failure in this application? That's the mindset shift that leads to better decisions. In critical service, the cost of failure almost always outweighs the savings from cutting specification quality. So let's take an actual real-world example. Just to give you kind of an idea of how important a lot of this is. We do a lot of work with a major U.S. brewery, and that brewery was losing thousands of dollars per batch because the beer had a more sour flavor profile than intended. And at first glance, the facility thought it would be easy to assume the problem was in the formulation, related or tied to the recipe, and then they looked at the materials that they were running through, thinking that maybe they had a bad batch. But in the end, the customer actually worked with us, and we were able to install a sight glass and camera system so that they could actually watch the fermentation process. And what they found was the fermenters were not being cleaned properly because the spray balls weren't spraying properly, which was leaving the tank improperly cleaned and sanitized. And that was allowing a bacterial, some sort of a bacterial contamination that was impacting all future batches. So basically what it came down to was having poor visibility inside the fermentation vessel and not being able to see that the spray balls weren't firing and that a portion of the tank wasn't being cleaned properly. Once our system was put in place, the customer said it was like night and day difference being able to view what was happening with the spray devices at the top of the tank. And it allowed them to show visibility which was not just about safety and maintenance, but it also directly shows how product consistency and profitability are just as important with these types of products. So LJ Star designs process visibility solutions for harsh process environments across industries such as oil and gas, petrochem, and many others. Each industry brings different visibility, safety, and specification requirements. Some will prioritize sanitary design, some prioritize corrosion resistance, focus heavily on hazardous location compliance, and others require performance in extreme temperatures or pressure. That's why there's no single sight glass solution that fits every application, and why we don't sell out of a catalog. The equipment has to be selected around the process, not the other way around, so we try and tailor our products towards your needs. And this is really where LJ Star aims to add value as a specification partner. First, operational impact equipment is specified to actual process conditions, not just catalog assumptions. Second, standards compliance. Documentation can support all sorts of requirements from DIN 7080 to ATEX to ASME to CRN. You name it, we will go out of our way to make sure that we have an offering that meets those needs. And third, technological innovation. Products such as Metaglass, Lumiglass, and related accessories help support integrated visibility solutions. And finally, worker safety, giving remote observation, explosion-proof options, and protective safeguards to help reduce operator exposure. In short, the value isn't just supplying hardware, it's in helping the end user choose the right system for the right application and make sure that these are going to function long term based on what the operators are telling us. So let me just try and summarize the key takeaways today. First, visibility is not optional. It's a functional part of safe and efficient operations, and as you've seen, there's a lot of upside to being able to see inside your process, essentially. Second, poor visibility increases the risk of safety incidents, waste, and downtime. Very true. If you're not inspecting your equipment, if you're not designing your equipment to the application, and if your equipment isn't the right equipment for the application, there are increased risks of safety incidents, especially. Waste and downtime, of course, will occur, but the biggest one is safety. Third, glass must be specified to the process, especially in harsh environments involving chemicals, temperature, or pressure. Very true. You want to make sure that the designs are designed to the specific operating conditions and make sure that you are meeting all of the safety requirements at that facility. Fourth, sight glass plus lighting plus camera equals the complete process visibility. Very true. It's best to purchase everything as a kit. You don't necessarily have to always have the camera, but the camera does add an additional level of safety and visibility that you don't have just by walking out constantly and looking through the sight glass. Fifth, proactive inspection is the first line of defense against any type of failure or false readings. Very true. Even though you're installing these sight glasses and cameras and lights, you still want to visually go out and inspect them and make sure that they are functioning properly, because your process can change and you want to make sure that these are working properly and that they are safe. And finally, the right partner brings application expertise and system level thinking, which is extremely true. Companies like ours, like LJ Star, are very, very good at coming up with designs that fit your application and make sure they work to meet all of your needs. If there's one thing I'd want everyone to leave with, it's that process visibility should be engineered and not assumed or necessarily cookie cutter purchased, because it should fit your application. It should be designed to meet all of your on-site needs. Now, as I know, this was more of an overview, so if you'd like to go deeper into any of these topics, there are several resources available at our website, ljstar.com. Those include the LJ Star YouTube channel, our sight glass safety videos, a step-by-step guide to sight glass selection, and the sight glass selection handbook. also a chemical and pharmaceutical application handbook, and a process lighting handbook. I find all those very useful. I've got quite a few customers that have downloaded and used those in the field as well. These resources are definitely designed to help engineers, operators, and maintenance teams make more informed specification decisions and avoid some of the common pitfalls when designing sight glasses and lighting at their facilities. So feel free to check that out at our website. And finally, thank you again for your time today. I know everyone's extremely busy, so I really appreciate you taking 40 minutes out of your day to listen to the presentation. If you'd like to discuss sight glasses, process lighting, camera systems, sanitary fittings, level gauges, or safety relief valves, we'd be glad to continue the conversation offline. If you have any applications you're working through, especially ones involving corrosion, pressure, visibility limitations, or remote viewing challenges, feel free to reach out to LJ Star directly, as we have a phenomenal inside and outside sales team just waiting to take your call. But at this point, I'd be happy to move into the questions portion.
Okay, great. Scott, thank you so much for that great presentation. In just a moment, we'll begin the Q&A session. Attendees, if you would like a certificate of participation for today's webinar, you can download one by clicking the View Certificate button. And if you have questions you haven't sent over yet, now's the time to do so. Keep those questions coming, and we'll keep pulling them from the chat and putting them in front of Scott to get to as many as possible. So at this time, let's begin the Q&A. The first question is, what sort of exotic manufacturing of exotic materials are expensive and slow?
With regards to exotic materials, they tend to be quite a bit more expensive, and they do tend to be a little bit slower with regards to delivery. Not so much on the manufacturing side, but more on the delivery. So it depends. You know, if you're talking about titanium or Hastelloy, Inconel, Monel, any of the high-end nickel alloys, it's going to come more down to how long it takes us to be able to get the materials from the suppliers, because they usually do have longer lead times and a little bit more difficult to get our hands on. Same with duplex, super duplex, anything special. And that's not only for the metals, but that also goes for glass. If you're dealing with any type of exotic glass or coated glass, such as sapphire or quartz, those tend to have almost double or even triple the amount of lead time requirement to get that material in. But once it's in the machining side, it is a little bit more difficult to machine, but it usually doesn't add much on the machining side once we get the material in.
Okay, great. The next question says, my sight glasses installed on vessels often are obscured by condensation from the process. How to choose between solutions to improve visibility?
This is actually a good question. We have this come up quite often, and we have quite a few different solutions associated with trying to keep the glass clean. So we do have wiper assemblies and spray nozzles are the two, or spray rings are the two solutions that we use most often. But it's trying to choose between which one you use depends on what your actual process is and what your product looks like. I have applications where customers have started using wiper assemblies, and the product was, for example, a dusty product, but would get on the glass and kind of gum up that wiper assembly. So it wasn't a good application. So in the end, we ended up using a spray device that actually kind of put up a barrier between the dusty product and the glass, and they used air to create that separation. So it's going to be really dependent on what the application is, what your product is, and also, you know, with a wiper assembly, do you have access to the window? If you're using a camera system, you may want something that's automated, and a wiper assembly may not be the way to go, because you'd have to have an operator go out and clean that glass and then come back into the operation room, which defeats the purpose of having the camera system. Whereas if you've got a spray ring and you can either use a fluid or some sort of air to clean that glass off remotely, that might be the better solution. So it's all going to depend on, a lot of the questions that we would ask you through the process when we're designing this, and determine what's the best fit.
Sounds good. The next question says, does LJ Star have recommendations for displaying camera feeds in the control room while contending with the site's firewall for the control system?
Yeah, that one's a little bit more difficult, especially for me without having one of my IT guys here. But in many of the cases that I've worked with companies, the best approach is to keep the camera systems separate from the main control systems and show the video in the control room through, say, either a approved display setup. Usually makes it a little bit easier to work within the site's firewalls, and just kind of keep that separate of the, of the system that they've got set up at the facility. A lot of times we have gone and set the camera system up and had it completely segmented from the core control network that's at the facility, and used it as only a pass-through to the video monitor in the control room. Otherwise, you can start to get into quite a bit of different things with your IT team, and you can set up managed video servers. You can, I was trying to think. The way to look at it is it's not part of the native, it's not a native control device. Basically, you want to try to figure out how to integrate and keep them separated is the easiest approach that I can come up with. Otherwise, you'll have to get with our IT team and have your internal team discuss options for getting around that firewall. It's the best I can say.
Sounds good. The next question says, we operate in a hazardous area and visibility has always been a challenge. What are the most important things to get right when you're specifying for explosion-proof environments?
The most important things are getting the area classification right. Making sure the equipment's certified for the specific, whether it be gas, vapor, or a dust. And then making sure that you confirm the temperature rating is safe for that environment as well. And it's part of a full installation. It's not necessarily just the light or the camera that has to fit the hazardous area. If you're doing the sight glass, you need to make sure that the accessories that are associated with that, like the seals, are what's required, and verifying that any of the wiring or the glands or any of these accessories are also compliant for those particular areas. But it's good to find all that out in advance, and especially with the temperature and the area classification is what we would need to be able to quote something like that.
Okay, sounds good. The next question says, our procurement team always pushes for the lowest cost option on sight glasses, as with all equipment, due to budget constraints. How do you make the business case internally for spending more upfront?
Well, of course, the lowest price isn't always often the best as far as your total operating cost, but with sight glasses in, say, a hazardous area that we were just asked, a cheaper unit can definitely create hidden costs, just because it's put in a more difficult environment, and it may require additional cleaning or replacement. You also want to try to make sure that any of the additional maintenance costs associated with the sight glasses as minimal as possible, and that's not always in some of those cheaper units, because there may be additional components. Like for some of our sight glasses, we prefer fused sight glasses in certain applications, and that fused sight glass is just a metal ring with glass in the center and then a gasket, whereas some of these other units, like a threaded NPT that's a non-fused, might have an additional set of seals, an additional piece of glass that has to be removed and replaced. So there may be other components associated with that build that may cost more in the long run. So we try to look at that total cost of ownership and decide, is it reliable? Is it going to work? What's the maintenance look like? Service life is a little bit difficult, as we mentioned in the presentation, because we don't always know, how long a product's going to last in a customer's particular application, because those can change regularly. But we want to try to make sure to get you the most cost-effective product that's going to last the longest in that individual application.
Sounds good. I know you already touched on camera setup, but the next question says, when does it actually make sense to add a camera versus just improving the sight glass and lighting setup? We get asked about cameras a lot, but I'm not really sure when they're warranted.
Well, the camera makes a lot of sense when people need to see what's going on without going out on the sales floor. Like I said, up here in the Northeast, we get a lot of bad winters, and we have some applications. I have some specific customers up here that have biogas applications where you may have to walk up a floor or two to see inside of a tank, and most of the walking is done outside in icy environments. And so they were looking for ways to keep their operators safe from having to go out into those applications. But essentially, if an operator needs a clear view, and you don't want to put them into some sort of a situation where either the time it takes to walk out and view and then back to the control room, or an area where they may be injured, it is best to look at some sort of remote monitoring, especially when you've got, this is coming up more and more where I hate to say this, but they've been laying off various plant managers, and the plant managers that are left are having to kind of coordinate between plants. So that somebody may have 2 or 3 plants within a company, and they want to be able to view but can't be at every facility, so they can actually remote view from one location and see the plants at different locations. So that's another area that the cameras make a lot of sense.
Sounds good. The next question says, we do frequent line changeovers and the CIP cycles are pretty aggressive. How does that kind of repeated thermal and chemical cycling affect sight glass integrity over time, and how does lighting impact that at all?
Well, the frequent changeovers, and especially with the aggressive CIP, it usually shortens the sight glass life through that repeated thermal cycling, the gasket wear. With the temperature changes, you see seal creep and chemical attack from the CIP process. So you have that gradual loss of clarity over time as the glass starts to cloud or etch. So you definitely want to make sure to inspect the glass regularly when you're dealing with those changeovers and CIP cycles. The biggest stressors in those applications are going to be your rapid temperature swings between your process and your wash down and your CIP. Again, when you're doing the CIP, you're going to be dealing with caustics and acids. I always tell people it's similar to your glass. The glasses that you drink with at home, when you run them through your dishwasher regularly, over time, you'll start to notice that they're not as crystal clear as they were when you first purchased them. And that's basically as simple as the high temperature from the dishwasher and the detergent used to clean the glass. With regards to lighting, lighting has a couple different things. First, if you have good lighting, it can reveal damage to the glass. Even though you're using it to see inside the tank, the additional lighting does enhance the visibility, allowing you to see things like haze or scratching or even residue on the glass sooner than you would normally. So it also helps with inspection. And then, depending on the light fixture, on how it's designed, certain light fixtures can actually add heat, creating hot spots and causing seals to fail over time. So lighting doesn't necessarily damage the sight glass as much as the overall process, but it does help enhance with regards to being able to view inside and then basically show you some of the imperfections that may be occurring on the glass.
Okay, sounds good. And we've got time for a couple more questions, but before we do that, we've had a few people ask about getting a copy of the presentation. I know Scott mentioned it at the beginning, but we'll send an email later today where you'll be able to access the recording. So please look for that from us. And also, you can find this webinar and more educational webinars, including ones featuring Scott, on our website. So yeah, feel free to do that. And also, again, please send in your questions. If we don't get to everybody's questions today, we'll get it to the presenter and the LJ Star team so they can answer it offline. The next question is, we recently changed our cleaning chemical and now we're seeing some fogging on the glass that wasn't there before. Could the chemistry change have affected the glass itself, and what should we be looking for?
Most definitely a chemistry change can absolutely be the cause, as it may be attacking the glass surface, the gasketing, or even leaving residue film that can show up as fogging on the glass. Some of the stuff to look for would be, is there any type of residue or film that can be cleaned off versus like a permanent haze when you're looking at the glass during these processes, if you're starting to see anything. If, for example, like the haze doesn't clean off easily, that would point more towards a chemical attack or a surface etching. So you're wanting to visually observe if there are changes when you're making these chemical changes, because it can attack the glass if it's not the same process that it was designed for. We run into that quite often where we have one or two plants supposedly running the same CIP cycle. One plant has perfectly clear glass, the other plant has glass that's hazed, and they're trying to figure out why. And normally when we start digging into it, we realize that they're not using the same strength cleaner that they may have been required to use. Somebody may have made a change that they didn't notice, or they felt that they needed a stronger run, and we tend to see fogging on the glass if it wasn't designed for that specific application. I hate to say it, a lot of times with the chemistry and that process and those changes, we don't always know what the overall impact's going to be, because it depends on the temperature that you're running that process with. It depends on the strength of the chemicals that chemicals that you're using in that process. The biggest thing is that you want to visually observe that glass after or throughout these processes to determine, we're starting to see etching as we've changed, the chemistry on our process. So you want to try to continually observe what's happening with the glass and determine if it is having an impact or if it's not having an impact. That's the best thing that I can say.
Okay, sounds good. The next question says, is LJ Star required to be one site to set up a camera angle and focus, or is it fairly easy to set up in case the camera needs to be removed for unplanned maintenance to neighboring equipment?
We're not actually required to be on site to set up the camera angle, but we can definitely come out on site and take a look at what you're trying to do with the camera setup. And then once it's installed, it should be pretty easy to adjust the focus or adjust the setup if you have to remove it for any type of unplanned maintenance and put it back. Because they'll be, as long as you're communicating with the control room, you should be able to see what you want the setup to look like and then reset it. Most of the camera equipment does come with various levels of software, and we have an we have a support group that if you are having issues with installation or any of the software, we can put you in contact with our team and have them troubleshoot and walk you through it if there are any issues.
Sounds good. One more question. We had a site with sight glass crack, likely due to repeated thermal shock. What resources do you have for quantifying how bad of a thermal shock a sight glass can endure and what the expected lifespan is for that?
With Metaglass, it is better at handling thermal shock because of the radial compression and the fusion of the glass. But any type of glass, when you're dealing with thermal shock where the change is too rapid, there is, normally these are installed on tanks, and a lot of the tank manufacturers have a range where the temperature can increase at this rate over this amount of time, and they usually let the operators know what that range is. Now, I know in the real world that doesn't always happen, because when you move from a CIP process that's a couple hundred degrees, and all of a sudden you're bringing in a cold product that might be 60, 70 degrees, as soon as the process is over, the tank is still extremely hot. So it's not all unlike taking a pan off of the stove and then running cold water on it and wondering why the pan warped. It's a lot like that. So we do actually have some documents that I can share after the presentation with you, because I think I should be able to get some of your contact information, but should be able to send you some of the recommendations with regards to that temperature change and how rapid or what's the lowest or highest that we would want that temperature change to be over a period of time, so that it doesn't destroy the glass. With Metaglass, we have made some changes to the glass where we go to a concave finish, trying to reduce any of those stresses that occur during that rapid temperature change. So we have gone out of our way to address that. I can't guarantee 100% that you're not going to exceed that limit and that you may get some micro cracks. But the upside to Metaglass is if you have a rapid temperature change and you do get slight cracking in the Metaglass, I've never seen one fail entirely where the glass is broken. It's just visual cracks around the edges, whereas if you were using a standard piece of glass, you most likely would have a catastrophic failure compared to the safety site glass that's approved for those type of applications. But again, I'll be more than happy to kind of put a little bit of information together for you and send it out with regards to what those temperature changes should look like and what amount of time is required so that you don't damage the glass over time.
Sounds great. Okay, everybody, that does it for time today, which brings our webinar to a close. We'd like to thank Scott and the LJ Star Incorporated team for today's presentation. And thank you to everyone for taking the time to join us today. I hope you all have a great day.